All right, scholars, so we're working on lesson 5.4. We really only have 2 other lessons for chapter 5. There are more sections in chapter 5 than through 5.6, but 5.7 and 5.8 we actually do later in the year. Like I pull it from this chapter and I throw it in a different one. So know that they will be done, just not when the book says to do it. This is when I have teacher prerogative. All right, so just know that we'll end with 5.6. So we'll get through the last 3 sections of this unit this week. All right, so with this one, we're actually just using what's called the triangle mid-segment theorem. Okay, so when you hear the word mid-segment, what kind of goes into your head? The middle, right? You think middle, right? Now it's not the median, like we know for a triangle that the median goes from my vertex to the midpoint of the opposite side. Oh, by the way, before I forget, your quiz tomorrow. Let's take a moment and pause. You need to make sure you know the following. If I have the orthocenter, circumcenter, incenter, and what was our other one? Centroid, right? The centroid. Those are all points of concurrency. You need to tell me which line segments make them, okay? So what makes the centroid? Let's go backwards here. What makes the centroid? What ones intersect? Okay, now I'm worried about your quiz tomorrow. Not tomorrow, Wednesday. Excuse me, Wednesday. Excuse me, thank you. It is Wednesday. Good save. All right. Everyone's like, Gregerson, no! I'm so sorry. Now that I had you all do a panic, okay, it is Wednesday. Yes, it is Black Day. Sorry. Did not mean to do that. It's online tomorrow? I'll fix that online. Everyone's like, I don't know if that's a good thing or bad thing. Way to find it. All right. When's the centroid? Guys, but you still have to know this. Even if the quiz is not tomorrow, you're supposed to already know it. What intersects to make the centroid? Okay, no. Guys, listen up. If you don't know the definitions of this stuff, I specifically told you this on Tuesday, you will not know. Those of you who are gone to bed. All right, we talked about this. You need to know the lines. Your choices are perpendicular bisector, angle bisector, median, or altitudes. You've got to know. This is when I told you that was a vocab section, you have to know it. Which one of those that I just listed, of those 4, make the centroid? No. This is the medians. Remember, the median's the center of the road. Centroid, so it kind of goes that way. Think centroid, centroid is center of the road. All right? The in-center. Think about what's always, if it's in center, it's always inside the triangle. So there's only 2 that were guaranteed to be inside the triangle, and that's your in-center or centroid. What is always going to be, if you draw them, are going to intersect inside? This is your angle bisector. Your circumcenter. This was the very first one. This one's your perpendicular bisectors. And then the orthocenter, again, I don't know why they ever picked the name orthocenter for this one, but this is probably the thing that I told you that you had to know besides vocab the most, is how to draw your altitudes. So remember, your altitudes help us find area of triangles, so you have to know that. But these, you've got to know. I love you. After a 5-day break, you should have at least looked over your notes once for the sake of your brain being sharp today at all. Okay? Make sure you know those. Now, we're talking about the mid-segment of a triangle. Now, this is what makes it really easy to remember what it is. All right, so remember the mid-segment of a triangle is a line segment, so that's pretty easy because it says a segment, that joins 2 midpoints of the sides of a triangle. So it just connects midpoints. So the mid-segment connects midpoints. So like right here, notice if I have 2 congruent segments, I know I have a midpoint. Segment XY would be considered a mid-segment. So you have your segment XY, you have your segment YZ, and your segment XZ, long as that line segment connects the midpoint of 2 of the triangle sides. So obviously, how many mid-segments should every triangle have? 3. Now, the fun thing is, when you draw them all in like this, what do they form? So it has a name. It's called the mid-segment triangle, okay? And it's just a smaller triangle that works. And so it's triangle, and you can name it anyway, but I'm going to go X, Y, Z. Now, it's going to have some really cool special traits. So what we're going to do is actually derive the theorem before we do it. We're going to actually show mathematically what we have. So here's what it says on here. The vertices of triangle RST are is at -7, 0, S is at -3, 6, and T is at 9, 2. M is the midpoint of segment RT, and N is the midpoint of segment ST. Show that MN is parallel to segment RS. How do I show if two things are parallel? If someone says just drawing it, you know that's not going to fly. How do I know if things are parallel or not? Trevor.
If they have the same slope.
Yeah, exactly, if they have the same slope. So this means I have to know slope, right? And then the next one says, and show the length of segment MN is 1/2 the length of segment RS. How am I going to do length? How do I calculate length when I have ordered pairs? I got to use distance formula. All right, what's the other thing that would probably be very helpful? Would it pay to have a diagram? What do you guys think? Does it have to be drawn awesomely to scale? And the answer is no. But at least should you have an idea what it looks like. All right, so let's make sure we do that. So just draw yourself quick vertices, my friends. All right, and then I'm going to put in my ordered pairs of triangle RST. All right, so we know R is over here at like -7, 0. I got S is at -3, 6, so that'd be somewhere about here. There's S. And T is over, oops, I put -7, 0. It needs to be here. So sorry. And then T is over at 9, 2. So somewhere over here, about at 9, 2 is T. All right, so far, that's my triangle. All right. Now remember, I want to show MN is parallel to RS. I don't have everything drawn I need, do I? I don't know where point M or point N are at, so I need to make sure we have that. We know M is going to be the midpoint of RT, so it's about somewhere around here. So that would have to be true. And they tell us N is the midpoint of ST, so somewhere about here-ish. I know that's a very technical term, isn't it? Here-ish is what we're going to have. Christopher, you're looking tired today. Did you travel for, no? Did you stay up a lot during break?
I had to wake up like super early.
Oh, so sorry. All right, so with this, there's segment MN. What do I not know about segment MN yet? I don't know its slope, but to find its slope, don't I have to know its endpoints? How do I find the endpoints? I heard it, use what? Not distance formula. I can't use ordered pair. It's not going to find it. Which one's going to help me find it? Midpoint formula. If I know it's the midpoint of a line segment, can't I use the midpoint formula? So I got to use midpoint formula before I can do anything. How cruel, right? So we have to use the midpoint formula. So let's find it. So let's use the midpoint formula. And let's find point M first. All right, so midpoint formula, it's the average of the x's, average of the y's. So I need to use R and T, right? So for M, I got -7 plus 9 over 2, and I got 0 plus 2 over 2. I got that to be, is a -7 plus 9 is 2, 2 divided by 2 is 1. 0 plus 2 is 2, 2 divided by 2 is 1. So I got the ordered pair 1, 1. Is that what you guys got as well? All right, I got to use the midpoint formula to find point N. So we're going to use point N here. I'm going to use 9, 2, and -3, 6. So I got here -3 plus 9 over 2, and I got 6 plus 2 over 2. All right, so my ordered pair for that one is going to be at about 3 what? 3, 4. So right here at 3, 4. All right, so now do I have enough information to start doing what I need to do? All right, let's do one thing at a time. Let's show first that they're parallel to each other. Remember, I want to show that MN is parallel to segment RS. So I just got to calculate the slope of both of them. So let's do the slope of segment MN first. I'm using that as a subscript so I know which one I'm looking at. Guys, should I have to write my slope formula down anymore? We did so many times when we did the equations unit. You should know it, but remember it's the change in y over the change of x. So if I'm looking for mn slope, I'm going to end up going 1 minus 4 over 3 minus 1. So I just went this direction from m to n. Oops, actually 1 minus 3. I flipped it around. Woo! Save that before I got bad. All right, so what do we get here? We got negative 3 over negative 2. Guys, isn't that a positive 3/2? Now, if we do this right, if we're showing that they're parallel, segment RS needs to give us the same type of scenario. So our slope of segment RS, so we got to use points R and S to do this. All right, so we're going to go 0 minus 6 over a negative 7 minus a negative 3. So I get negative 6 over negative 4. Guys, does that simplify down to a positive 3/2? All right, do they have equal slopes? So they're what to each other? The slopes are equal. Yes. So guess what? We just shown that segment MN is parallel to segment RS. Woot woot. Good. Now what do we have to do? Now I gotta do my distance formula. I need to show that MN is half the size of segment RS. So which one do you guys want to, excuse me, isn't it segment RS, right? Which one do you guys want to do? Big one or small one first? Big one? All right, so let's do segment RS first. So I'm looking for its length. We know the distance formula. You guys told it earlier when we were doing the spiral review. So when I plug this in, I'm going to go negative 7 minus a negative 3, that quantity squared, plus 0 minus 6 squared. That should be a 0. So we get on here, that gives me a negative 4 squared plus the quantity a negative 6 squared. So it's 16 plus 36. I get the square root of 52. Now, this is when it does pay to know how to simplify radicals well. The square root of 52 can be simplified more, and in simplest form, that ends up being 2 times the square root of 13. So right now, you need to know this part. So the length of segment RS is 2 times the square root of 13. If I want MN to be 1/2, okay, if I want MN to be 1/2 of this, it needs to be the square root of 13, right? So if we do it right, it needs to be square root of 13. So let's find it real quick. So length of segment MN, using our distance formula, we're going to go here. I'm going to go 1 minus 3, that quantity squared, plus the quantity 1 minus 4 squared. So we get here a negative 2 squared, and this would be a negative 3 squared. If I square it, I get a positive 4 plus 9. Did I get the square root of 13? Okay, what do we know then? We know segment MN ends up being 1/2 the length of segment RS. Guys, we did that all with coordinates, and that's called a coordinate proof, but it shows it the same way. Yes, ma'am?
Oh, sorry, for the 2 to the radical, whatever, does it have to be plus?
No. Distance formula, because we're using distance, it's always what? When you're solving an equation, that's when it has to be plus or minus. Nope, that's one of those clarifications you just got to know because it's so hard to know when do I do it. Notice here I didn't have an equal sign unless I put it in there, and that was just to let us know the length of the segment. This would only be positive. Great stuff. Now, so this proves this is true. So guess what? You have a theorem that tells you all of that anyway, okay? This works for any mid-segment. If I draw a mid-segment in, it's always going to be parallel to the side it doesn't touch. It's always going to be half its length. So this is called the triangle mid-segment theorem. So let's just fill it in. A mid-segment of a triangle is always going to be parallel to a side of a triangle, and its length is half the length of that side. So the cool thing is, if you know you have a mid-segment, you know it's going to be parallel to each other, and the mid-segment is always smaller. It's always half of it. Yes, ma'am.
For the two blanks on the first page under the mid-segment of a triangle.
This is just called the mid-segment triangle. All right. So here's the thing. A lot of people try to complicate this. Here's the rule. Memorize the theorem. You've got it made. Okay? Memorize, as long as you know they're parallel. Can I use all the stuff I know about parallel lines with these? No problem. As long as I know that like the third side is, the mid-segment is half the side. Guys, could I write it like this too? Can I double the mid-segment to equal the third side? So if I know one of the two, either the mid-segment or the side, should I be able to calculate the other one with no problem? That's how easy it's meant to be. Okay, don't overcomplicate this stuff. All right, so let's look at this first one here. Looking at our triangles drawn, are M, P, and N all midpoints? Yes, because I have the two congruent segments. Great, which means PM and PN, we know automatically are going to be mid-segments. So guys, is there any law saying that I shouldn't mark the fact that they're parallel to each other? No, I should be able to get it pretty quickly. Now on the first one it says find the length of segment JL. Guys, now remember, no bar over it means you're physically finding the length for me, right? So guys, how do I find the length of segment JL? Solomon. Yep, I'm going to multiply the length of segment PN by 2. So 2 times 36 should be 72. Whew, tough work. In fact, you didn't even have to show me the first part. You just go 2 times 36 equals 72, and I'd believe you when you're doing it. Michael, take the part out of your mouth. Thank you. All right. What's the length of segment PM, my friends? Yeah, we know, is it 97 PM? Yeah, it's going to be half it, right? So when we're working with it, let's make sure I remember this in. I never plugged in my computer today. Here we go. We just know it's 1/2 of 97. Now I got to change my pin. So it's just going to be 97 over what, guys? I just leave it as 97 over 2 and your life is easier. All right, now here's one. What's the measure of angle MLK? What is it going to be? I heard it. 102. Why is it 102 degrees? If I can write 102 now. Yeah, exactly. If I have parallel lines, doesn't JL become my transversal? And doesn't that make corresponding angles congruent? So yeah, so it's going to be 102 degrees. Guys, that's how easy this is. If I remember corresponding angles, doesn't life become real easy? Yes, ma'am?
Why did you make segment NP parallel to LK instead of PN parallel to L?
PN is
J?
PN bisects segment LK or intersects the segment. It can't be parallel to it.
No, I mean like PN parallel to JL.
It is. I did.
Oh, sorry.
I had arrows right there.
Oh.
All right. Example 3. Guys, fill it in real quick on your own. Go. Fill it in real quick on your own. All right, guys, why for number 3 is the measure of angle BFE 44 degrees? Connor.
Corresponding.
Yeah, because if I have parallel lines, corresponding angles are congruent. AB, well, remember, if I know I have a mid-segment, good question. You with me, these FD is the mid-segment for AB. I know the length of the mid-segment, and I know it's half of its size. So wouldn't I double it to get the longer side? So just go which direction you need to go. A lot of times I think it's easier to double the mid-segment than it is the other one. Yes, sir?
Will this lesson be on the quiz?
Yes. Because your quiz, unlike what I tried to tell you earlier, is not until Wednesday, so you're good.
But tomorrow's lesson.
Right. Totally right on. All right. So next one. Find the value of n. Find the value of n. What do you guys know? When you look at this diagram, what do you know? All right, a little bit louder. What do you know? What's drawn in your diagram? I have a mid-segment, and I have a side that it's going to be parallel to. So if I have the mid-segment theorem says it's the mid-segment's half the length of that third side. We also know they're parallel to each other. So this one's all about the length. Now, how many of you like fractions? Okay, you lie. Don't put those hands down. I know better. Guys, good try. You told me you like fractions. No way. I'm not going to take 1/2 of this. I'm not going to go 1/2 the larger segment to get the smaller one. Can't I use the idea that I'm going to double the smaller one to equal the larger one? So I'm going to go 2 times the mid-segment to equal the third side. Right? Is basically what I'm doing. So if I do that, I get 2n plus 28 equals 3n plus 12. When you're solving for it, subtract 2n from both sides. Did you guys get n to be 16? Now, is there anything wrong, those of you like fractions, I'm going to go back to you, okay. Is there anything wrong with just going 1/2 of 3n plus 12 is equal to n plus 14? Could you solve it that way and should you get the same answer? Yes, but do you really want to work with the fraction if you can help it? The best thing to do even in that scenario is to still multiply both sides by what? 2, to get rid of it. So it's a lot easier just to double the mid-segment. All right, now the next one says triangle XYZ is the mid-segment triangle of triangle WUV. What is the perimeter of triangle XYZ? What's the perimeter of triangle XYZ? What are we going to do, my friends? You know, I know you're all tired, but I'm really like ready to calling you cold turkey to make sure you guys are awake. So, Solomon, what am I going to do? Yeah, I just need to find the lengths of the mid-segment sides, right? Now, guys, don't overly complicate this, all right? If I know this side is 8, half of that, isn't that going to be 4? So really, when you're drawing in the mid-segments, you literally could do this. Isn't that really true? Because you've already got the mid-segment, you know, the midpoints drawn in, you know, oh yeah, that's half of the whole side. It really is going to be the same thing. Notice when I do that, what's so special about all 4 of those triangles? Look at all 4 of the small triangles. They're all congruent by side, side, side. So basically, when you draw in mid-segments of a triangle, do you have a lot of other things that you could actually work with too? Yeah. We're not doing that right now, but like just notice that stuff is there and those are all valid. So yeah, so we know XZ is just going to end up being half of 8, which we know is 4. We already know that ZY is 3. I have to just solve for XY. Well, XY is going to be 9 over what? 2. Okay? So that's 9 over 2. Oops, wrong one. I labeled the wrong spot. 9 over 2, I know that one's 4. Perimeter tells me I have to add all the sides together of the smaller triangle. So that's just going to be 4 plus 3 plus 9 over 2. Now guys, there's times when mixed numbers are a lot nicer. 9 over 2 is the same thing as 4.5, right? Now look how easy that is to add. What's 4 plus 3? Plus 4. It's just 11.5. And we should probably say units if we're being exact, but they didn't give a measure. Guys, that's how easy this stuff is. Now, obviously your homework supplement, a little bit harder, but hints on the homework supplement. Factoring and systems of equations are your friends. All right, label your diagram. Sound like a plan? All right, so in here you have another about 9-ish minutes or so. How about starting your homework? I would say do the homework supplement because that's harder. And then I can help you with it. Sound like a plan? All right, awesomeness.